taking derivative using the chain rule. The chain rule is, so let's say we have the derivative with respect to x of f of g of x. This is a composition function. We have function g inside function f. So when you take the derivative of that, so for example, x squared plus 5, and then you have the whole thing raised to the 8th power. So this function, we have a parabola, the x squared plus 5 inside an 8th power. Okay, so that is equals to f prime of g times g prime of x. This is called a chain rule. So the chain rule in words is the derivative of the outer function times the derivative of the inner function. So let's use the first problem as an example. So we have x squared plus 5 raised to the 8th power. If you, without chain rule, if you only know the power rule, you have to open up the 8th power. So that becomes many terms, and then you have to take the derivative term by term. With the chain rule, you can treat everything inside the parenthesis as one item, just one item. I don't care what it is. So the 8th power is a power rule, so you have to bring the 8th power down, whatever the inside is, raised to the 7th power, 8 minus 1. And then you take the derivative of the inner layer. So what's the inner layer? The inner layer is x squared plus 5, so the derivative of x squared plus 5, that is equals to 8 times x squared plus 5 to the 7th power. So here is the derivative times 2x. And then this is the answer. And then you might ask me, hey, can I just get to the answer in one step? The answer is yes. With a little bit of practice for this kind of problem, you can just get to the final answer in one step. With a little bit of practice, you can do it. The reason I showed the step in the middle is because I am trying to show you how to do chain rule, so I have to show all the steps. All right, so let's do another problem. So another problem, let's change to a different color. So this time, how about this? Let's do the derivative with respect to x, the inner function, or sometimes I call it the inner layer. I have negative 2x to the 5th plus a square root of x. The outer function, I use 100 power. So this one, you bring the 100 power down, and then whatever that is, raised to the 99 power, and then you take the derivative of the inner layer, right? So the inner layer is negative 2x to the 5th, and then the square root, I change that to 1/2 power. So you take the derivative of that plus x to the 1/2 power by chain rule. So you have 100 times negative 2x to the 5th plus, you can put that back to square root because we are not touching this term anymore. And then this one is times negative 10x to the 4th power, and then bring the 1/2 down, x to the 1/2 minus 1. So that is the answer to the second function. And then the next function, let's change to a different color. Let's change to orange. So we have the derivative with respect to x. We have this one, let's use a square root for the outer function. So the outer function is a square root inside. We have e to the x plus pi. So let's see if you are able to do this in one step. So first of all, we bring the square root down, and then the square root minus 1 is negative 1/2. And then inside, no change, because we are taking the derivative of the outer layer. And then you multiply. When I do chain rule, I always use a big dot for multiplication. So whenever I see a big dot on my work, I know that I am applying the chain rule. And then derivative of the inside is, the derivative of e to the x is still e to the x. The derivative of pi is equals to 1. Nope, the derivative of pi is equals to 0 because pi is a constant. X is the only variable, so you add a 0 to it. So that is number 2. And then moving on to number 3, we switch to a different color. So how about blue? So the derivative with respect to x, how about e to the negative x to the 3rd plus 10. This is also a composition function. We have a, how about this? Let's don't use a 10. Let's use x to the 10th power. So we have a 3rd power and a 10th power inside an exponential function. So first of all, when you take derivative, you are taking the derivative of e first. So e to the anything is e to the anything. So e to the negative x to the 3rd plus 10. And then by chain rule, you have to multiply the derivative of the exponent, negative x to the 3rd plus x to the 10th power. So overall, you have e to the negative x to the third plus 10, and then this gives you what? Negative 3x squared, right? And then plus 10 x to the 9th power. All right. And then let's do one more. Let's do one more. We can definitely fit one more. Let's use this bright green, lime green. So d dx, derivative with respect to x. How about this? A constant raised to 8 minus x to the fifth. Well, what is the derivative of this exponential function? The derivative is ln the constant. So you have ln the constant, and then multiply whatever the power is, which is, this one. So you have the derivative of a to the x, so that is equals to ln a times a to the x, right? So, and then you multiply the base raised to 8 minus x to the fifth. Am I done? No. We have a fifth power. We have a function inside the exponent, so we have to multiply the derivative of the power, 8 minus x to the fifth. So overall, we have ln pi, and then multiply pi raised to the 8 minus x to the fifth, and then we multiply, the derivative is 0 minus 5x to the fourth. You don't need to write the 0 out, but I believe that when I do the lecture, it is more clear. The notes is more clear when I write the 0 out. Because otherwise you may think, okay, where did the a go, right? So if I say 0, people know that, all right, when you take the derivative of a, you get a 0. Okay, so that is the end of this introduction. If you like it, give me a like, and I will see you in the next video for more practice. See you there.